Okay, so in this lesson, we're going to continue to look at applications of systems of linear equations. So today's applications are going to involve mixtures. Sometimes you're mixing two kinds of candy, or sometimes you are mixing solutions like in a chemistry lab, right? And then we're also going to look at travel, applications that involve travel. So these ones are a bit tougher than the ones in our last lesson, though that's subjective. Some of you might not think so. So we got a couple examples, and then I'll have you work on your own. All right, so first we have an auto mechanic. He keeps bottles of antifreeze, which is the chemical glycol mixed with water. It's a solution. There's some glycol and there's water in it, and you mix those together and it makes antifreeze that you put in your car, right? So he has it in two strengths, right? The first bottle is 20% glycol, 80% water, right? And the second bottle is 35% glycol, 65% water. So suppose that the mechanic needs to create 12 quarts of antifreeze that's 25% glycol, right? So he's got some 20% and he's got some 35%. So it makes sense that if you sort of mix the two together, you could get a percentage in between 20 and 35. So you could get a 25% mixture. So how much of each bottle should be in the mixture? So first, define your variables. So sure, X could be the amount, right, which is measured in quarts. Number of quarts of the 20% solution. The word solution just means mixture of two liquids, right? So, and then we could let Y be the number of quarts of the 35% solution, right? And so how did I decide, how did I pick those? How did I decide what my variable? I could pick any X or Y, right? And in fact, I think in your packet they picked L and H. Yeah, doesn't matter. But how did I decide what to let my variables represent? Yeah, how much of each bottle should be in the mixture, right? So the answer to the question is how you set up your variables. How much of each bottle should be in the mixture? How many quarts of 20%? How many quarts of 35%? That's how I decide what my variables will be. Let X and Y be the answer to the question. Okay, so then we try to organize all this information into a table. The amount in quarts of antifreeze of 20% glycol. That's what they asked us, and we had already decided that's going to be X. And the number of quarts of 35% was Y. And how many quarts of the mixture am I looking to make? 12 from the problem, right? We want to create 12 quarts. All right, what is the percent glycol in the 20% glycol? 0.2, yeah. It's 20%, but when you do arithmetic with percentages, you typically change them to decimals. So we'll write that as 0.2. And 35% we'll write as 0.35. And what do I want my percentage to be when I make my mixture? 0.25. I want it to be 25%. Okay. So antifreeze, remember, is made up of some glycol and some water. It's a solution of glycol and water. So if I had, this is a little aside over here, 100 quarts of antifreeze, that's 20% glycol. How much of that 100 quarts is pure glycol? 20 quarts. Yeah, 20% of the 100, that's 20 quarts is pure glycol, meaning 80 quarts of it is water, right? If you were to try to separate them out, you would end up with 20 quarts of glycol, 80 quarts of water. So that means you have 20 quarts of pure glycol. So how do you figure that out? How did you get the 20 quarts?
20% of
20% of whatever we had, right? 20% of 100 was 20. And you multiply 0.2 times 100. So multiplying feels natural when you have a number, but you're going to do the same thing. Now we just have a letter, right? So we have X quarts of antifreeze. 20% of it is pure glycol. So you multiply. 0.2 times X tells you how much pure glycol you have. 30%, 35% of Y quarts, you multiply those, and that tells you how much pure glycol is in the second mixture. And then how do I figure out how much pure glycol is in my final mixture? 12 times 0.25. And what's a quarter of 12? No, it's 3. There's a typo in your packet, right? A quarter of 12 is 3. So fix that. Typo in packet. It says 4. It's supposed to be a 3, right? Okay, so we've organized all the information that they gave us, and now we have to write a system of equations, which means I've got two unknowns, x and y. I need two equations. What equals what? Sure, in your packet, L plus H equals 12. I used x and y, right? X plus y equals 12. Right? If I take X quarts and Y quarts and mix them together, I'm supposed to get 12 quarts. Okay, what else? Yeah. This is quarts of glycol, right? So you're contributing 0.2x quarts of pure glycol from your 20% solution. Your 35% solution is contributing some pure glycol, and you want that to come out to 3 quarts of pure glycol. So that's our two equations. Two equations, two unknowns. I'm going to let you try solving that at some later time. The answers are 8 quarts of the 20% solution and 4 quarts of the 35% solution. You can't solve it?
You just told us the answer.
Oh, well, you can still solve it. Make sure you can get to that answer. So yeah, you've got the answers. You can practice solving later. We're trying to, the hard part of these kinds of problems is pulling the information out of the word problem and setting up your equations. Okay, so one more kind of problem. This is a travel problem. Okay, so a similar approach can be used when we're solving problems that involve distance, rate, or speed, and time. So for all of these problems, we're going to use the formula rate times time equals distance, or RT equals D. All right, Irma flies her plane with the wind. So when you're flying with the wind, you actually travel faster, right? And if you travel against the wind, you travel a little bit slower because the wind is pushing against you. Okay, so she flies with the wind 450 miles, and it takes her 3 hours. And the return trip against the wind, she's going slower because the wind is slowing her down. It takes 5 hours. But the distance is the same, right? If you go one place and then go back, the distance you travel is the same, it's just reversed directions, right? So we want to find the speed of the wind and the speed of the plane. So we're going to use those things, the things they asked us about, to define our variables. So what do you want to call your variables? W and P? Good. So W will be the speed of the wind, and P will be speed of the plane. And you could easily just use X and Y. If X and Y are your favorites, you can stick with those all the time if you want. Or you can pick variables that help you remember what they represent. Okay, so for the trip to Saratoga that was going with the wind, okay, how fast was the plane going? P plus W, because the wind is helping the plane go, right? So P plus W the wind is, the tailwind is actually speeding the plane up. All right, and then how long did it take to get to Saratoga? 3 hours. 3 hours. Okay. All right, and then we'll save distance for the end. On the return trip, what's the speed of the plane? P minus W, right? Because the wind is actually slowing the plane's speed down. So we have the plane speed and then take away the wind speed because it's slowing the plane down. It's dragging it, making it slower. And how long did that trip take? 5 hours. Okay. Now, in general, rate times time equals distance, right? So just do a quick example. Like if you're going 60 miles per hour for 5 hours, how far have you gone? 300 miles, right? So you just do a quick multiplication. Your speed times your time gives you your total distance traveled. All right, so I'm just going to multiply my speed times my time. 3 times P plus W and 5 times P minus W. So now I have to write a system of equations. So writing a system of equations, what equals what? Yeah, because they actually told us the total distance, right, is 450 miles. So this is 450, and this is also 450, right? The distance in both directions is 450 miles. So I have 3 times P plus W is 450, and 5 times P minus W is also 450, because your trip there and your trip back are both 450 miles. So again, I'll let you solve these on your own some other time. It turns out the answer is 120 miles for the plane per hour for the plane, 30 miles per hour is the speed of the wind. If you want to practice your solving techniques, you have the answer to check it. Okay, so it turns out that this first problem in your activities is actually the hardest. I'm going to ask you to save for last. And just go on to number 2 and come back to number 1 at the end.